Our first chapter is on patterns and sequences. Now, that is a very, I'll say, rich topic. And there's really no end to the complexity to find patterns and explain the patterns and extend the patterns that you observe. We're obviously not going to look at the topic completely. We're just going to sort of get a taste because that's all we are looking to do. So we're going to start with exercise 1.1, very first one. And I'll show it on the screen for now. At an elementary school level, you may start with sequences of pictures. They might be very difficult or very easy. So before you give little Timmy a sequence, make sure it's something that he can actually do, because they also get very complicated fast. So if we look at the first one, do you see a pattern in the pictures? And can we explain what it is and use that to find the next picture hiding behind the question mark? What is the pattern if you have to explain it? Just in words, and whatever words you want to use. It seems to be something with the diagonals. They go this way, this way, this way, this way, this way, this way. So the next one is top left to bottom right. So now I'll just leave the screen like this. Number one. The next one is going to be like that. And how many words you use to explain it doesn't matter. Whatever works for you. It's sometimes difficult to explain the pattern and get someone to see it the way you see it. So the next one. Is there some pattern that you notice? Because we're relying on nothing but our intuition or some past experience that you might unconsciously use, it can be something that someone sees, but someone else doesn't see it at all. Do you see a pattern there? What is the pattern? Pretend I don't see it. How do you explain it to me? Yes.
I would say cut down the middle.
Yeah, every other one is cut down the middle, vertical line.
Yeah, and then cut a half again horizontal.
Yeah.
And then it's a half down again.
Yeah. Let's say vertical, yeah.
And then a diagonal. So there's always the vertical going down, but then it's the diagonal and the, I want to call it an H.
Sure, an H, why not? The other ones alternate. So we end with a diagonal, and the previous alternating one was, we end with a vertical. The previous one was a diagonal one, so it should be an H one. Okay, let's draw an H. H, like so. Everyone happy with that? We're just starting. Is there a pattern in number 3? What is it?
The shapes have, it starts with 8 sides, then 7, then 6. Then
Yeah, the number of sides go down by 1 every time. And if I continue that pattern, the question mark one is a triangle. Not necessarily a pattern that I can continue indefinitely, but I can at least find the question mark. Last one, number 4. I see something there. These can be very complicated, but I made hopefully fairly simple ones. First of all, is it a big or a small one that's next? Definitely a small one. They alternate. What could it be? Small triangle?
Small equilateral triangle.
Ooh, very good. True, true. They do come in pairs. The shapes are sort of the same. Sort of the same. So it should be a small triangle. Now, I'm not going to pretend to draw a perfect triangle, so just squint a little bit when you look at my drawing. But there you go. So that's fine, and certainly at an elementary school level, it's a good introduction. But it's also difficult to explain and work with a lot, mainly because I don't have much drawing skill. So what we could do to give ourselves a chance to explain things and work with things a little bit more and notice other patterns is to switch to sequences of numbers instead of pictures. So let's look at exercise 1.2. Now again, we have 0 experience right now. So, and looking at a topic that has no limit in its difficulty, things can get confusing very quickly. So when I'm looking at a sequence of numbers, looking for a pattern, I might have 0 experience and not see any pattern. Or it might be simple enough that there is an obvious pattern that I can explain. So really, there is no wrong answer right now because I have no method to systematically figure anything out. We have to eventually develop that. So in number 1, 1, 4, 7, 10, 13, do you see anything obvious? What is the pattern in words, would you say? Any words you want. Add 3 each time. So it's perfectly fine to say it in words right now. It's really all we can do. And that allows us to find the next one as 16, because I'm adding 3 every time. So I don't want to go too fast, but that first one is something that I would hope everyone can see. Then in the next one, 1, 4, 8, 13, 19. Continuing from the previous, adding something from one to the next, is not the same thing. 1 to 4, I'm adding 3. 4 to 8, I'm adding 4. Then I'm adding 5. Then I'm adding 6. So there's a pattern in what I'm adding, which is sort of a next level kind of pattern. So I could say let's just call them the jumps, because that's an easy word to use. The jumps increase by 1. Now, my explanation in words, it doesn't have to be super clear right now. We can elaborate by just discussing it. Every time the jump that I'm making is 1 bigger. Jump of 3, 4, 5, 6. So next to the jump of 7, which would get me to 26. So elaborate the words in the explanation if you want to, but it's not super important right now. As long as we can see why I say 26 for the next one. Anyone not sure? Anyone very sure of the 26? Anyone? I have no questions at this time. Those 1 and 2 sequences, we should definitely be able to see and explain. They're at our level. But it can very easily get out of hand, and I don't know what the next sequence is going to be. So let's look at it. 1, 2, 4, 8, 16. They don't seem random. They don't feel random. And I can only go on my feelings because I have no experience with this, which makes it a little tricky. Is there a pattern that you see? Can you explain it? Yes. Every number doubles itself. Absolutely. And you can say it exactly like that. It's all good. Every number. Ooh, that's a little. Doubles itself.
Double the previous number?
Double the previous one. Yeah. So we do want to be a little careful. Every number is double the previous. That's a little bit more clear, but it's all good. So our next one is going to be 32. Okay. Well, we've been seeing some patterns. Good. So the first two were based on basic arithmetic in that I was adding something. The number 3 one was still basic arithmetic. I was just multiplying. The fourth one. Now, ironically, if you show that to little Timmy one day, it's not hard to see a pattern. But what he could say is, oh, you added a 0 every time. Well, we understand what he means, but is that a good way to say it? A clear way to say it? Adding a 0 every time? Is it adding? No, so maybe attaching a 0 might be a nicer way to put it. That is the pattern, but what is the arithmetic behind attaching a 0?
Like 10 to the power of 1. And then
Let's not confuse him with powers, but you're right. Simpler than that. If you tell Timmy it's powers of 10, he's like, no idea what you're saying. Multiplying by 10 is the same. So there are different ways to say it, and if we can base it on the simplest arithmetic possible, we're going to have a better time to explain it and use it. Multiply by 10 every time. I know my explanations aren't very clear, but I don't need them to be right now. So our next one's going to be 100,000. 100,000. But very soon these sequences could get a little bit more complicated. We're still aiming for basic arithmetic. It's not always possible because it's so open right now. Your answer could be, I see nothing. And that's also okay. Number 5, 1, 4, 9, 16, 25. They don't feel random, but it's just a hunch. You might look at that and see nothing. I will give you a hint that I'd want to see something in this one. So going on our experience that we're slowly building up, we can go for adding something. 1 to 4 is adding a 3, then we're adding 5, then we're adding 7, then we're adding 9. That is certainly a pattern. And that's what she saw first. It works. How should I say it? Adding, increasing odd numbers. Does that make sense? And our next one is therefore, so that was the part that you should say. 36. Is there another pattern or another way to explain a pattern? Yeah, another pattern. Yeah. Is there another pattern? That still gets me to 36. Another way to say it. Another way to look at it. Yeah.
That each number is the square of the one before it.
I think I know what you're trying to say, but the way you're saying it isn't quite right. It's not the square of the number before it, because if I look at 9, it's not the previous one squared, but it does have something to do with that. If I write down, this is an important one, so it's worth spending time. If I just write down the sequence again, 9, 16, so on. Sometimes it's convenient to look at the position. I put it in brackets underneath to not confuse myself. That 4 is in the second position. That 9 is in the third position. That 16 is in the fourth position. What is the link between the number in the sequence and the position? It's the square of the position. Square of the position. So we just conveniently call them square numbers, and we'll come back to them a little later. Either way, the next one is going to be Oh, we have the fifth one, right? Next one here. Position 6, 6 squared. Either way, it's 36. There was nothing wrong with either one of these. Different ways to see a pattern. All right. We have number 6. Well, let me know if I'm going too fast or anything. Number 6, 3, 1, 4, 5, 9. Ooh, they feel very random to me. Don't know. Because I have no experience with much at this stage, if you feel like, oh, I don't see anything, that's a perfectly fine answer. I, at this moment, don't see a pattern. That doesn't mean there isn't one. It just means my numbers, I have 5 numbers. It's very much dependent on something that you can use as experience, intuition, call it whatever you want. And maybe my intuition is horribly bad and I see nothing. And that's okay right now. Because these sequences can be very complicated. Without a specific method or some structure to help me figure them out, it's really just a shot in the dark. But maybe your intuition is better. Is there anyone seeing anything? I honestly don't see anything for that one. Doesn't mean there isn't one. I could have made that sequence a year ago with a pattern in mind. I just don't remember. Yeah.
I don't know how to say it properly, but like the number like 3 gets like if you add 3 to 1 it equals 4, and if you add 1 to 4 it equals 5.
Oh, that is nice.
And 5 to 4 equals 9. Or yeah, adding 4 to 5 equals 9.
Now let me ask, is there any reason for me to feel bad that she saw it and I didn't see it? No, I don't feel bad at all. Because I have no method. It was just sort of intuition and what you see in the moment. And she happened to see it and I didn't. And that's okay. But that definitely works. So let's say it. Ooh, I'm out of space. Let's say it for sure. That's a good one. I honestly did not see it. Didn't try very hard either, but. What number are we on? 6. So to get the 4, we add the 3 and the 1. To get the 5, we add the 1 and the 4. So we're adding the previous 2 numbers. And the next one should then be 14. That works. Awesome. That is awesome. All right, success. Glad she was here. Whew. 7, 11, 23, 35, 47, 59. There are 2 patterns here. Different. Which one do you see first? Yeah. But see, we're very different than little Timmy's gonna be. We are sort of trained to quickly use the previous examples as experience and expect the next one to be somewhat similar. And because we've been adding stuff for many of them, trying to add the same number every time is something we go to first, and it definitely works. We can add 12 every time.
We also start with 1, 2, 3, 4.
1 second. One at a time. I need to write it down. Add 12 every time. Then the next one is going to be according to that pattern. And then you say?
They start with 1 and then it goes to 2, 3, 4, 5.
No. If we do the plus 12,
Oh.
what's the next number? I just want you to contribute. I know it's 71. Or, now you say, what I find kids go to much faster than I do, actually try and avoid it because it's complicated, is to look for patterns in digits instead of the whole number. Because then, like she said, the tens digit goes up 1, 2, 3, 4, 5. So you expect the next one to be a 6. What happens to the ones digit? 1, 3, 5, 7, 9. It could be a little complicated. What comes after 9? One argument is that maybe they just loop around. 1, 3, 5, 7, 9, 1, 3, 5, 7, 9, maybe. So then, according to that, and I'm not going to bother writing that down, let's just say individual digit patterns. According to that, the next one will be 61. Neither one of them is wrong. Because we have so few numbers to try and see a pattern, we are really limited to whatever numbers we have to work with. And if there are only 4 or 5 numbers, we might think it leads us in a direction other than the intention, or someone else might see something else. None of them is wrong at this stage. But it's interesting how kids go for digit patterns, where I try and specifically avoid digit patterns because they're really hard to explain. Anyway, there are 2 options. More complicated, perhaps. But also, if I look at the jumps in between, then it actually isn't that complicated. One more. 16420. Again, I have so few numbers to work with. It's tricky. If I had more numbers here, really the evidence would help, and I would hopefully see a pattern more easily. But this is what we have. Do they feel random? We're very conditioned to feel that there should be an answer. I see a sequence of numbers, there has to be some pattern. And if I don't see it, there's a problem with me. I could have made those randomly. Don't know. Could have. I didn't, but I could have. Don't assume at this stage that there necessarily is a pattern you have to see. It's so hard. It's a hard question. But there is a pattern here. What could it be? They seem very random to me. I'll give you a clue. Let me just write down the 16420. Let me write them down. What's this number? 8. 16420. I'll give you a clue. Yeah, not a full clock. That's my clue. And this one is just there to show that things can be much more complicated. You don't have to see this in any way, and you'll never see it again. Just to illustrate that not everything is just adding the same way or multiplying. It's a little bit more complicated sometimes, and hard to see because of that. Add 5 every time, but count on a circle. So if I start at 1, 1, 2, 3, 4, 5 puts me at 6. 1, 2, 3, 4, 5 puts me at 4. 1, 2, 3, 4, 5 puts me at 2. 1, 2, 3, 4, 5 puts me at 0. 1, 2, 3, 4, 5 puts me at 5. Are you expected to see that? No, not at all. Block it out. It never happened. But just know that in general, these patterns and sequences can be very complicated.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.